Hi, everyone, and welcome. It's the top of the hour. We'll get started. Today's webinar will help you unlock the power of geocells as a value engineering solution for your mine infrastructure. We'll discuss how the GeoWeb 3D soil stabilization system offers a better approach to soil stabilization challenges when accessing sites over soft ground, controlling and containing stormwater, protecting geomembranes in basins, tailings, and heap leach pads, and reclaiming slopes at mine closure. Through 3D confinement and the strengthening of infill, less material is required and on-site waste rock can be used. The GeoWeb system offers increased speed of operation, lower maintenance, safer installation, and lower total cost of ownership, helping you meet environmental, social, and governance goals while improving production. I'm JP, the business manager for Presto Geosystems. I meet with specifier and contractor clients to secure and support our international network, driving new opportunities with a focus on roadways, mining, environmental remediation, hydrocarbons, and wind energy. We manufacture industry-leading erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluation from our in-house design engineering team. Here are a few things I hope you get out of today's presentation. Understand the benefits of geocellular confinement for high-performing, long-lasting mine infrastructure. To explore mine applications for geocells in haul road, slope, channel, and containment pond solutions, and to learn how 3D geocellular confinement can produce higher performance and lower maintenance mine site solutions. We'll share a few case studies, and there will be time for questions at the end, so please enter them in the questions window. You can also provide feedback or additional questions through a follow-up email or by contacting us directly at prestogeo.com. I'll also have my contact details on the screen at the end. For now, all will be muted. Thank you. The 3D GeoWeb cellular confinement system is perfect for the mine industry as it stabilizes unstable soils vertically and horizontally in the applications of load support, slope protection, channel armoring, and earth retention. Today's presentation will focus on permanent and economical solutions with the GeoWeb system for a number of challenges facing the mine industry: stabilization of soft soils for access to site and haul roads, control and contain rainwater, protection of geomembranes in basins, tailings, and leach pads, and reclamation of slopes at mine closure. Through 3D confinement and by strengthening the fill, less materials required and waste rock can be beneficially reused on site. The GeoWeb system offers improvements in operation, maintenance, installation, and safety at a lower total cost, giving your mine site some powerful value engineering solutions. The GeoWeb system is our version of GeoCell technology and consists of two main attributes. The first is the cell size. The cells come in three diameters: small, medium, and large, and varying cell depths. Cell sizes are selected following an evaluation of project-specific needs and site conditions. The ultrasonically welded seam, where all the connecting points are, is very important to the function of a geocell. The stronger the seam strength, the better the performance of the geocell will be. A strong seam allows for heavier infill, steeper and taller slopes, and better lifetime performance. GeoWeb is the original geocell, produced for consistently strong welds at cell junctions while also maintaining semi-rigid ductile properties within the cell walls, high stress crack resistance, and overall toughness and long-term durability in the environment. Our geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce your weld strength and environmental stress crack resistance, and that are offered in some competing products in the name of increasing cell wall stiffness. To avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all elements of the GeoWeb system is much more important than stiffness alone. Here we see a typical GeoWeb panel as it comes tri-folded on a pallet. GeoWeb is lightweight and requires no specialized equipment for installation. Sections flex like an accordion so they can follow the natural contours of the worksite without being confined to a rigid set of dimensions. The infill, or what you put into the container, is the second important attribute of a GeoWeb system. An important benefit is that low-quality aggregates, sand, or on-site reclaimed material can all be used to infill the geocells. Using reclaimed sand or aggregates can save a significant amount of money on materials and transportation costs. We can also remove fines if drainage is desired, as the geocells provide the confinement and aid compaction of cohesionless soils. Without fines, we can significantly improve drainage and let water flow freely through the system, preventing poor pressure buildup and overall cross-section failure. The ability to use these low-quality sands and aggregates with friction angles in the 20-degree range really sets the GeoWeb system apart from GeoGrids and other geotextiles. Those products require high-quality materials with high friction angles to achieve their optimal performance. With the GeoWeb system, materials with low friction angles are fine, as the GeoWeb panels reach their full potential even with these poor materials and can provide significant cost savings. As a value engineering option, the GeoWeb system can often reduce the cross-section required by half. The three primary elements of any geocell system, cell walls, internal junctions, and connectors, must perform uniformly as a complete system. So any incremental improvement in one characteristic, like cell wall stiffness or ESCR, is only valuable if a complementary improvement has been made in the other components of the system. GeoWeb is manufactured using a proprietary blend of high-quality virgin high-density polyethylene, and our proprietary formulation has stood the test of time for over 40 years. For most typical sites, GeoWeb will retain its durability for greater than 100 years, with lab testing indicating 149 years without degradation, even at full exposure to the elements. We stand behind our numbers so you can deliver certainty in the solution and build with quality materials you can trust. Made from high stability, inert materials, GeoWeb geocells are your permanent stabilization solution and will not degrade, leach, or release microplastics into the environment. GeoWeb does not contain any intentionally added PFAS, and based on this understanding, GeoWeb is not expected to pose a risk of release of PFAS compounds into the environment. Our base resin is the same material used in environmental applications like geomembranes and other environmental barriers to protect against the spread of harmful toxins. And our products have been third-party tested by accredited geosynthetics laboratories, confirming long-term stability against environmental factors such as weathering and oxidation. Additionally, GeoWeb and our accessories are 100% made in the USA under strict quality assurance and environmental control processes, sure to comply with all requirements for the Build America, Buy America, and the Infrastructure Investment and Jobs Act. Presto's GeoWeb system is equipped with numerous design and construction components that increase strength and speed of installation, each of them with specific strength values, so calculations and modeling replicate real-world forces, and the solution is designed for the project needs instead of as a commodity one-size-fits-all product. These system components are all the supporting pieces that help the GeoWeb protect the surface and base layers and also ensure relatively uniform performance of the interconnected system, thereby protecting against damaging effects of non-uniform deformation and differential settlement in response to applied loads. These components make it safer, faster, and easier for installation. The ATRA key is the first component for a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers your slope or channel. It allows for a faster installation of the GeoWeb and will last the lifetime of the project, ensuring your slope is protected and the GeoWeb system will not fail under anticipated loads. The specific engineering values of the ATRA key will ensure the system holds up to loading over time without corrosion, as seen in staples, or the failure of underperforming cable tie systems. Our spec sheet calls out specific engineering values for this patented connector, and the ATRA key requires no special tools, generators, or compressors, nor any three-handed acrobatics like cable ties or two-piece connectors. All the ATRA key power with a simple insert and turn positive connection. As slope angles increase, the driving force of your infill material exceeds the available frictional resisting force, and additional anchorage is required. The ATRA anchors hold the GeoWeb to slope and penetrate into the ground. If corrosion resistance is required due to project conditions, Presto has an HDPE ATRA speed stake designed to work with the GeoWeb and offer higher resistance to extraction than rebar or J-hooks. For steep slopes, a slope where the native soil is highly erodible, or over a surface that cannot be punctured, such as a liner, tendons can be used. The ATRA tendon clips transfer the load from heavy infill material to the tendons and to the crest anchorage system. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together. So we go from problem to design to construction solution with a system where the modeling replicates real-world forces. Now let's talk about how to take advantage of the benefits of geocellular confinement. The first application we'll highlight is load support. The GeoWeb system stabilizes unstable soils vertically and horizontally, and in load support applications offers various benefits for mine clients. GeoWeb geocells were invented for supporting heavy loads over soft soils, the perfect solution for haul roads in mine installations. Before giving specific examples with case studies, first we'll explain how and why geocells work so well for load support. GeoWeb was invented for solving a military problem, how to cross beaches with heavy military equipment. The Army sought a quick to deploy road solution, and a Presto engineer, Gary Bach, collaborated with Steve Webster of the Waterways Experiment Station to weld strips of polyethylene and form the first geocells. The system evolved to include UV stabilization and other improvements such as perforation, texturization, and connections, but the concept of geocellular confinement and the particular strength properties of HDPE have been proven over 4 decades of GeoWeb load support. Likewise with the use of low quality and low friction angle infills. Here we can see the stresses on the subgrade with an unsupported subgrade on the left and GeoWeb reinforcement on the right. Notice how there's a complete elimination of the highest stresses at the surface with GeoWeb reinforcement. The stresses are reduced and distributed over a wider area, which we call the mattress effect. This mattress effect reduces the stress reaching the subgrade and leads to a significant decrease in deflection and rutting. Let's get a bit deeper into how that works. GeoWeb geocells can alter the geometry of a soil pressure bulb beneath an applied load through this mattress effect. When a load is applied to a geocell reinforced layer, lateral earth pressures develop within the infill material, which is confined laterally by the geocell walls against movement, and in turn develop upward shear resistance along the wall interfaces through the interconnected network of cells. In essence, this lateral confinement converts horizontal earth pressures into upward resisting shear forces. When combined with suitable base reinforcement, such as an enhanced woven geotextile, it becomes possible to construct over very weak subgrade materials, including those with standard penetration resistance values less than 2 blows per foot, which is a CBR value less than 0.5%, where most planar geosynthetic products, such as geogrids, would otherwise fail. When a vertical load is applied, those active earth pressures in the loaded cell push back against the passive earth pressure in the adjacent cell and form a stable system. Being confined, the soil responds passively. The infill is limited in its movements, represented here by the yellow arrows. The cells adjacent to the loaded cell provide passive resistance, shown in the diagram by the red arrows. The load is dispersed over a greater area in the lower layers, as each cell helps support the ones around it. The geocell cell walls also transfer hoop stress, which is important in keeping the system intact and creates the mattress effect. The strength of the seams around each cell, the material properties of the individual strips, and the connection methods between panels are all important factors in determining how the geocell system can improve load-bearing capacity. Strong seams, semiductal resin properties, and integrated connections are critical to a well-performing system. The GWeb system and accessories are specifically designed to work together and be an effective, permanent solution for roads in soft soil locations. In a load support scenario, vertical deformation can only occur with either compression or compaction of the soils or through a lateral movement of the soil particles. By spreading out the load in a classic granular fill approach, you can reduce the compaction of near surface soils, but only with cellular confinement can you assure there's no lateral shifting, which leads to rutting. The mattress effect reduces the stresses reaching the subgrade. And by eliminating that lateral particle movement, the GeoWeb system can stabilize the surface, eliminating your need for constant maintenance. Here we see the impressive load support benefits of an 80,000-pound loaded dump truck or standard AASHTO-H25 loading parameters on a partially filled GeoWeb panel over soft subgrades. We see how the cells push back against each other and support the load, and that only the adjacent cell needs to be filled for this support. A great benefit to using the GeoWeb system is you do not need to have every cell completely filled before your road is usable. This can reduce construction time and materials, using the road as its own access point for construction. GeoWeb provides a system with less rolling resistance, less required maintenance, less expenses needed for fuel, and less structure required to support those loads, all with better production, better cycle times, better operational costs, and a better installation. A great value engineering solution for your site access and your haul roads. The 3D structure functions well in remote areas where clean aggregate is scarce. Compact GeoWeb sections ship efficiently to your job site and require less trucks to transport materials. On-site sand infill is used so that costly aggregates won't be necessary. Nearly any locally available granular infill, sand, and even waste rock can serve for the GeoWeb geocells in your projects. In the majority of cases, the GeoWeb system can also reduce your cross-section depth by up to 50%. GeoWeb allows stabilization with a reduced cross-section, making it ideal for underground haul roads. Let's look at a specific example for a haul road in a case study. This case study is for a mine site in South America and is a great example of the power of geocells as a value engineering solution. GeoWeb geocells were incorporated into the design of a haul road at an active mine in Suriname, with heavy loading over soft subgrades and local scarcity of quality angular aggregates as it was the mine startup. The prepared subgrade strength exhibited a California bearing ratio value of 2.5%, consisting of saprolite and clay. Anticipated loading included CAT 785 haul trucks, 275-ton vehicles, and the haul road useful design life of 10 years at 250 movements per day. Surface loading calculated to be 151,750 pounds, with surface contact pressure 101 pounds per square inch and 55% of the total 550,000 pound weight on the rear axle of the haul trucks. GeoCells offered a value engineering design option with multiple benefits. The sticky clay soils made the road impassable with every hard rain, and adequate aggregate materials for a standard construction solution were not to be found. GeoWeb geocells offered a value engineering option with just one 6-inch layer or 15-centimeter layer of geocells being able to support the heavy haul truck loading over soft subgrades and reduce the total thickness from 60 inches suggested by standard design guidelines to 30 inches. GeoCells dramatically increase the shear resistance of the infill, which allows the use of lower quality fill to carry concentrated loads that would otherwise require crushed aggregate and prevent localized near surface shear failure. Here's that one layer of 15-centimeter geocells being installed. For an efficient and cost-effective solution. The infill was locally available coarse river sand, known as small miner's residue. And the GeoWeb haul roads function well, even with the hard tropical rains. The results of the GeoWeb installation offered notable benefits. A great reduction in the total cross-section needed, reducing it by 35% with a coarse sand wear surface and by 50% with an aggregate wear surface. The estimated savings per kilometer are about $150,000 US, or about $100,000 per mile. Since installation, there's been a reduction in road maintenance costs of over 65%. There are no downtimes due to rains, and there have not been any ruts observed since installation, multiple years now. There's less vehicle maintenance and less fuel required, better productivity, and better operational costs with safer site conditions, and the expansion opened before the scheduled date and under budget. All in all, a very satisfied client. Project calculations included an analysis of bearing capacity improvement to evaluate the combined benefits of lateral confinement from the geocells in conjunction with the tension membrane effect of the underlying high-strength woven geotextile to confirm the proposed approach would meet all the design requirements. The analysis indicated the stabilized section would offer a substantial increase in the allowable bearing capacity over existing subgrade conditions, without which it would only have an allowable bearing capacity around 20 to 30 psi at best. An analysis of hoop stresses under the working loads was also performed to verify the geocell system components would be able to withstand the demanding load requirements. Hoop stresses were compared to the ultimate tensile strength of the perforated cell wall, as well as the strengths of the internal and the mechanical junctions. In the case of the junctions, ultimate strengths for all three primary modes of potential junction failure, shear, peel, and separation or splitting, were compared to the fully developed hoop stress under working loads to calculate factors of safety for each mode. For cell wall, the factor of safety against cell wall rupture was also calculated. As shown, all of the system components were verified to meet the design requirements. I invite you to use our free preliminary project evaluation service and see how we can help you save money and time for your mine site. With a bit of information from project parameters, we can run calculations and determine the ideal solution to resolve your site's soil stability problems. As a value engineering option or as part of your initial design recommendations. Visit prestogeo.com for more information. Our next application for GeoWeb will be for slope protection. The GeoWeb system stabilizes unstable soils, and in slope protection applications, that means we can control erosion while at the same time sustaining vegetation with steep slope angles. The GeoWeb system allows flexibility in a mine slope reclamation solution. And GeoWeb allows vegetation of tall, steep slopes. Very steep slopes. GeoWeb also allows you to suspend a protective layer to vegetate or hard armor over geomembranes without the need to perforate the liner for your anchor system. And as we see here, able to sustain vegetation and control erosion as part of that protective layer. Here's another example of the GeoWeb system with tendons over a geomembrane. The anchor system with ATRA tendon clips allows for a safe and strong installation without the need for stakes or perforation. The ATRA tendon clips transfer loads from the geocell wall to the tendon and the tendon to the crest anchorage. Here we see a typical crest anchor as a dead man pipe with the yellow tendons connected to it. Next, we have a case study to share for mine slope reclamation, this one in Peru. As we can see, the slopes are very steep. And their cut slopes have angles greater than 70 degrees with much erosion. A complete and complex solution was required, including in this case the design and construction of integral rainwater channels with energy dissipators, all with the goal of managing stormwater and preventing slope erosion with little to no maintenance long term. Long-term protection, and a complete solution to control erosion, reclaim mine slopes, and control stormwater, thanks to the GeoWeb system. Here's another look at the GeoWeb slope protection system from one of the world's largest nickel mine sites in New Caledonia in the South Pacific. This slope protection system included a staked GeoWeb slope using ATRA anchors. The system has to stand up to extreme weather events, including cyclones with heavy rains, 24 inches in 24 hours, and also strong earthquakes of magnitude 7 in the region. All this with 45-degree slope angles. And here, with the infill placed, using on-site waste rock from the mine, we stabilized all the slopes with GeoWeb geocells. We saw an introduction to GeoWeb channel protection in the previous section, and now we'll detail the GeoWeb mine channel protection system. So I've got a simplified diagram to show how the different system components interact with the GeoWeb to form a complete system. We'll talk about each of these components, and I want to stress that when I say channel, I'm talking about protecting an area that can be the full width of the channel plus the side slopes, just the bottom plane of the channel, or even just the side slopes like an embankment or dam structure. Full flexibility here for where you want to protect. The process for building up a channel protection goes something like this. To begin, we have our channel with standard dimensions and side slopes. Depending on the infill, a geotextile separation layer may be required. Then the GeoWeb panels are put in place. And note how there's a turn at the top of the side slopes. This is important for anchorage and also to prevent water from flowing under the panels. We have two options for anchoring. First is using ATRA anchors or ATRA speed stakes. These are placed along the channel and at the crest. The second is to use tendons and a crest anchorage system. So all the anchorage is at the crest of the side slopes or embankment, not along the channel face. Then the cells are filled with the desired infill material, and the system is designed to create a stable channel surface, even when the maximum velocities and shear stresses occur. The use of the 3D GeoWeb channel protection system is much more effective than two-dimensional solutions that are subject to scour. The fill material that is confined in each flexible cell is protected against erosive forces, making the entire channel or embankment more stable. 2D solutions such as erosion control blankets or cementitious blankets do not protect the channel from the hydraulic forces of the water, so the channel can fail even with these 2D protection systems in place. Those 2D alternatives are also prone to uplift and won't allow any excavator cleanout or other long-term maintenance. The GeoWeb channel protection system provides protection with a variety of anchorage and infill options to best suit your project needs. Here we see channels with vegetated infill, aggregates, and concrete. Cellular confinement improves the hydraulic performance of conventional channel protection materials. Presto has done extensive testing with the hydraulics lab at the University of Colorado State, and their lab has a static drop of over 80 meters or 260 feet for nearly limitless flows through their lab flumes. The CSU tests gave us formulas to calculate solutions for flows in vegetated GeoWeb channels up to about 9 meters per second or 30 feet per second, in aggregate channels reducing rock size by 2 to 10 times compared to riprap or the Abbottson Johnson or U.S. Army Corps of Engineers methods, and in concrete channels with flows of more than 11 meters per second, over 36 feet per second, with the GeoWeb system surpassing the flow limits of the lab flumes. Vegetated channels are not typical solutions for mine installations, and aggregate channels are often used for very mild slope installations, like this example of an outfall channel for Rio Tinto, or this example with shallow embankments in Arizona. The GeoWeb channel infill can be waste rock, readily available on site, and less costly than importing fill. For extreme flows and a permanent worry-free solution, concrete infill is recommended, as used in this spillway in Peru. And these remote site installations for San Andreas and Tyrone. There are many concrete GeoWeb channels at the Yanacocha mine. And it's worth a comparison to traditional methods. Traditional methods often open the possibility to failure points, in addition to their longer construction times. If there's any differential settlement or seismic activity along your channel, an inflexible solution should not be chosen. We're going to look at a case study for a high flow mine channel in Guatemala. GeoWeb allowed for a resilient and fully armored seamless channel without the need for expansion joints and the potential failure zones seen with traditional poured channels, all with a reduced cross-section. GeoWeb geocells can be incorporated to handle high-flow stormwater in remote locations, and their long-term resiliency makes them ideal for mine closure applications where environmental restrictions hold sites to consistent and permanent high performance, yet site access often only allows for occasional monitoring post-closure. Expanded durability standards are especially important with increased frequency of record storm events, and if either seismic activity or differential settlement is expected. As our case study will discuss, this mine site in Guatemala experienced record storms and strong seismic activity, and the geosynthetically enhanced channel armoring delivered consistent performance that stood up to the challenges. The channel had anticipated hydraulic flow of 425 cubic feet per second, about 12 cubic meters per second, and a 16.86 feet per second, or 5.14 meter per second velocity over a length of 400 meters. There were rapids included in the channel, and the client wanted to allow for excavator entry as needed for future channel cleanout. The mine site was originally considering an 8-inch reinforced poured concrete channel and looked to optimize design while maintaining a trapezoidal channel formation. Design calculations supported a 4-inch geocell system to allow that excavator support, and the mine site preferred to compromise with a 6-inch depth for an additional factor of safety. This was still 2 inches thinner than originally budgeted, so already offered considerable savings in concrete costs. The design included a non-woven geotextile as separation layer, 6-inch geocells, with polypropylene tendons and a load transfer system, and 4,000 psi concrete. The G-Web channel protection design incorporated our strong polypropylene tendons, ATRA key connectors, and ATRA tendon clip load transfer devices. First, the channel bottom was filled, and then the side slopes, working from top to bottom. Note the yellow tendons and the dead man anchor at the crest. These components are determined project by project based on the details of the specific channel needs. By doing the channel bottom first, workers were able to traverse the channel and allow easier access for the crew. Rapids were incorporated into this part of the channel design, with the G-Web geocells transitioning seamlessly into these step rapids structures. And here we have the joining of the rapids with the rest of the G-Web channel. And here's a drone view of the G-Web channel installation, with the rapids here. The G-Web channel protection system allowed for a resilient and fully armored seamless channel without the need for expansion joints and the potential failure zones seen with traditional port channels. The channel is now in its 6th year of performance without incident, even with record storm events and strong seismic activity in the area, with soil saturation, overflowing rivers, and even landslides. Geocells with concrete infill have the long-term resilience and economy to be considered a best practice and are considered among the solutions with highest long-term performance results from the U.S. Bureau of Reclamation's 10-year canal lining study. Here we see a comparison of allowable velocities and shear stresses for various channel lining alternatives from the U.S. Department of Agriculture. The G-Web system provides protection and flexibility, as shown in this mine closure channel in Mexico, using big riprap fixed in place with grout for a rockfall area. Or with these rapids in a Peruvian mine installation, with various options for anchorage and installation, and various options for infill. All in all, a system of complete channel protection for your project needs. Our in-house engineering team will gladly provide an evaluation for your mine channel and help provide a G-Web channel solution that satisfies your project needs. Our final application today will be earth retention systems. The G-Web earth retention system can offer global stability and the support of surcharges. Even with seismic activity and differential settlement. Retaining walls serve to contain soils and protect utilities or storage tanks, and offer global stability for very steep slopes, like this example in Central America. G-Web walls also function as containment dikes with or without vegetation. Unlike traditional block walls, GeoWeb walls can withstand reasonable differential settlement, hydrostatic pressure, and seismic conditions. Our team of engineers can help with the retaining wall design, and we also offer free design software licensing. Visit prestogeo.com Earth Retention for more information or to request your own copy of the MSE wall software. The GeoWeb system stabilizes unstable soils vertically and horizontally in the applications of load support, slope protection, channel armoring, and earth retention. GeoWeb offers improvements in operation, maintenance, installation, and safety at a lower total cost, giving your mine site some powerful value engineering solutions. Part of our complete solution is our technical assistance. The engineering team here at Presto Geosystems works closely with project engineers and consultants, offering a free project evaluation service. The form is on our website, prestogeo.com, and you fill it out with as much information as you have, including attaching documents such as geotechnical reports, project site pics, or other info, and it comes directly to us. And then within a few business days, our in-house engineering team will provide a complete evaluation, including infill recommendations and anchorage requirements. We'll work with you to get the best design for your project, whether it's a value engineering solution or the preliminary design work. I would also like to introduce a new web-based software, PrestoGeo P3, where you can plan projects yourself within this portal. This software offers a suite of geotechnical calculation tools designed to support engineers, contractors, and project owners in completing value engineering evaluations using GeoWeb geocells and GeoBlock and GeoPave porous pavements. Check out the software at prestogeop3.com. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specs, so you can deliver certainty and build with materials you can trust. No disclaimers or concerning fine print. One of the biggest questions we get is about cost, no surprise there, especially if this is new technology for you or your area. Having an idea of how much the GeoWeb system costs compared to other stabilization techniques is very important. Our case studies shared today hinted at some of that cost savings, and here's another look with a basic comparison for the GeoWeb system for a load support application, in this case, a gravel surface road. This comparison shows the difference in both price and cross-section depth for an aggregate-only unreinforced section, a section using geogrids and geotextiles, and then two sections showing the use of the GeoWeb system, one with aggregate and one with salvaged on-site materials as the infill. You can see the GeoWeb system is both thinner and less expensive than the other methods, significantly so when on-site material is beneficially reused. About a 40% savings can be realized compared to the geogrid or geotextile section, which does not allow for the use of most salvaged or on-site materials, as a high friction angle, well-graded materials required with the use of grids and textiles. Of course, your aggregate costs and distance to quarries may vary, but this will give you a general idea of the savings that you can achieve. I invite you to use our P3 program and compare cross sections accordingly and cost it out to see the best solution for your particular project needs. We've made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars you completed. Your webinar dashboard will keep a record of on-demand webinars along with the PDHs earned. Note that certificates for live webinars are managed separately than the on-demand dashboard, so you won't find your certificate from today in there. Instead, you'll receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. Then in 2 to 3 days, you'll also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard and other helpful resources, including a link to this recorded webinar. If you do not receive either of the previously mentioned emails, please check your spam folder. Additionally, here are my contact details or the general info@prestogeo.com. We thank you for your time and interest in value engineering solutions for mine infrastructure with the GeoWeb system. You can see more case studies, installation guides, and videos on our webpage, prestogeo.com, as well as our YouTube channel. Here are my contact details. The Presto Geosystems team and I look forward to helping you with your next mine project. I'll now answer questions, but if I don't get to one that you asked, or if one occurs after we close our webinar for today, please reach out to us, info@prestogeo.com, or you may contact me directly. My contact details are on the screen. We look forward to working with you. All right, our first question. Well, the first couple are about getting the webinar. I've answered those. Yes, it will be posted. Yes, you'll get a link to the recording. The first question about GeoWeb is what did the storm channel consist of in material type? So we showed a few different stormwater channels. The case study we showed was from Peru, and the slope reclamation was GeoWeb filled with topsoil and vegetated. And the channels, the stormwater channels, were concrete-filled GeoWeb with energy dissipators built into that same concrete. Next question, do you have any projects done for the U.S. Forest Service or the Bureau of Land Management? Yes, absolutely. Check out our Geo Gallery at prestogeo.com for more information there. Or if you have a specific state you're looking for, circle back to us and we can send details accordingly. Likewise, if you have any specific application in mind, we can help there. Have we run deflectometer tests on GeoWeb roadway applications and determined the resilient modulus improvement of just the virgin fill material? This would help pavement design specialists model the use in linear and non-linear elastic layer analysis programs. With that, I will point you to our Chief Design Engineer, Brian, who can kind of talk through the roadway design applications. Yes, we have those details. Some of those numbers are proprietary, and some of them will depend on the wear surface that you're incorporating. We're happy to work with you on that and provide a preliminary evaluation for your road design. So again, check out the free project evaluation service and we're happy to get those details to you. Next question, is it possible to receive the slides for future reference? Yes, we can share a link to that in our follow-up email. You may also find this on demand in our webinar dashboard and go back to it and watch it as many times as you wish. Next question, has GeoWeb been used in active stream beds and active stream banks in lieu of gabion structures? Yes, absolutely. We have many case studies of this, and you may see it there. Check out our Geo Gallery at prestogeo.com, and you can find many examples. A couple comments saying the last few minutes have been cutting out. I hope you didn't experience any audio-visual issues and that it was an isolated event. Please do check back for the on-demand version, and you should be able to see the full presentation, hopefully uninterrupted. Next question, is the cost benefit slide based on current costs for 2024? It's kind of taking an average of costing. It was produced in 2023, has not been updated, but if you have a specific area in mind with details for gravel costing and fill costing, distance to quarry, things like that, for your particular site, we could help you run those costs. Again, take advantage of our free project evaluation service and let us do the heavy lifting for you. We're happy to run the numbers. Next question, when will you get your PDA certificate? If you have participated in this live webinar, watch for an email coming to you from GoToWebinar in about 2 hours. Next question is asking specifically for distribution in the Pittsburgh area. Our business development specialist, Lauren, will follow up with you on that. Next question, can a building be installed at the top of a GeoWeb wall? How far away? You can incorporate all kinds of loading as a surcharge, live traffic loads in roadways, buildings, parking lots, things of that nature. It will have to be a certain distance set back from the fascia edge, and it depends often on the type of loading and the wall height, as well as the reinforcement used. Generally speaking, a safe distance back at least 3 feet, but it depends on the type of reinforcement used. Again, please take advantage of our free evaluation service and let us run the numbers specific to your project, and we can determine the exact setback as well as the reinforcement needed if it's a reinforced wall. Next question, can geogrids be used for road enforcement? Yes, of course. Geogrids have their place. If you have readily available crushed aggregate on site, geogrids make a very good and cost-effective stabilization technique. Typically for road solutions, GeoWeb GeoCells can offer a reduced cross-section compared to grids, as well as the ability to use lower friction angle and thus lower cost materials. Again, you may run a side-by-side comparison. Many grid manufacturers have a project portal similar to our P3 and will let you analyze a certain cross-section, pull up their version for the grid of your choice, and pull up the P3 version with GeoWeb GeoCells and run a side-by-side comparison and see which is a better fit based on costing and availability in your area. Otherwise, you may also use our RFPE, Request for Project Evaluation service. That's a free preliminary evaluation service. Let our in-house engineering team run the numbers for you. Unfortunately, that's all we have time for today. There are a few more questions I did not get to, but we have already run over our time limit. So I thank you all for your time and interest today in value engineering solutions for mine infrastructure with the GeoWeb system. I'm JP, or Jose Paulo, and I look forward to seeing you again. Thank you. Take care. Be well. Bye-bye.